Hi, good morning to all the attendees and hope you're all doing good. Thank you for joining us today and welcome to our session on cutting edge PV inverters, optimizing generation and advanced module technologies. I am Priya Sanjay, Managing Director at Mercom India. We would like to thank our sponsors of today's webinar, Hopewind. Hopewind is a global private listed company headquartered in Shenzhen, China. Founded, I hope you're able to see my screen. We would like to thank the sponsors of today's webinar, Hopewind. Hopewind is a global private listed company.
We are not able to see your screen, Priya.
Okay, let me just check. Yeah.
Yeah, now it's okay.
Yeah, we would like to thank the sponsors of today's webinar, Hopewind. Hopewind is a global private listed company headquartered in Shenzhen, China. Founded in 2007, it is a leading provider of green power solutions. By utilizing superiority in digital innovation, power conversion, and control, Hopewind creates intelligent, safe, and efficient clean power solutions. The company aims to empower its partners and drive the green energy transition from grid following to grid forming, bridging sustainability for all. Let me introduce the speakers of today's webinar. We have Gautam Samanta, the Head PV Technology, Juniper Green Energy. Mr. Anuj Mathur, the Regional Manager, North, Hopewind. Sunil Panigrahi, the Country Manager, India at Hopewind. Mr. Shiv Shankar Mishra, Head Operational Excellence and Commissioning at Sterling and Wilson. Before we get to the presentation, some quick housekeeping items. You can use the questions panel on your toolbar to type in questions at any time during the webinar today. We'll answer relevant questions at the end of the webinar, and we are recording this webinar and a link will be sent to all the registrants. Before we start with the panel discussion and before handing it over to Sunil, I would like to give a brief introduction to the sector, what is happening in terms of solar project development. As of June 2023, there are over 66 gigawatt of solar projects that are in operation. This includes rooftop solar, which is about 15% of the total capacity, and the other 85% is large-scale solar projects. And India's large-scale solar project pipeline stands at 67 or close to 67 gigawatt, with another 62 gigawatt of projects which are tendered and pending auction at the end of June 2023. The solar industry has been transitioning towards string inverters. In 2022, string inverters accounted for 53% of the total shipments, while a central inverter accounted for 47% compared to 49% in 2021. This is the inverter shipments to India. Most of the solar projects in India have transitioned to monocrystalline modules. The market share for monocrystalline modules in 2022 has increased to a significant 70% compared to only 10% in 2019. New technologies like thin film, bifacial, HAD are making inroads with 11% share in 2022. Here are some of the criteria that has been considered before selecting the PV inverters. I've just laid out a couple of these criteria. So now I hand over to Sunil Panigrahi, who is the country head of Hopewind, to present the new age inverters that Hopewind is bringing out.
I think it's mute, huh?
Yeah.
Hi, Sunil, you are muted.
Hi everyone. Yeah. Dear friends,
Yes,
colleagues,
now
and esteemed guests. Thank you very much for joining us in this fantastic webinar. We'll be discussing some cutting edge technology modules as well as inverters. So I would like to present a small presentation of Hopewind so that to introduce our company Hopewind to our guests here. So let's start. Can you see my screen?
Yes, we can.
Yes. Yes.
Okay, so I have put a small crisp presentation for you all. So as you can see, we have divided the presentation in 4 parts. So we'll be discussing about Hopewind in the first part, and about the residential and CNI PV inverters in the second part, and utility inverters and some projects in third parts. What the projects that we have done, some pictures. So about Hopewind, Hopewind is established in 2007. As you can see, we are working in 5 business sectors, which include solar, wind, energy storage, SVG, and VFDs. So we are actually working as a power conversion equipment supplier. Through all these 16 years, our focus was on R&D and on project development and product development. So our company has also been listed, IPO listed on the main board of Shanghai Stock Exchange in 2017. So through all our lifespan, we have supplied around 100 plus gigawatt of power conversion equipments to the industry, mainly to the wind and solar segments. And these are the company milestones. As we have discussed, we have established in 2007, and our first batch of wind converters was supplied in 2008, and our first batch of solar inverters was supplied in 2011. So it's almost more than a decade for us for supplying solar inverters in the industry. Basically, we were mostly focused on Chinese local market, and now we are supplying it all over the world since last 5-6 years, and even before that. And we have launched our CND inverters, as you can see, in 2013. And as I've discussed, our IPO is on 2017, and our total generation of revenue crossed to 2 billion CNY in 2021, and we are growing every day. So these are some of the company facilities that we have. So our HQ and R&D center is in Shenzhen. So we are established company in Shenzhen for wind converters as well as for solar inverters. So we have factories in Suzhou, a very fantastic factory which I have visited, and it was a fantastic state-of-the-art R&D division as well. So we have factories in Xi'an and Yuan, which were producing our wind converters, our utility inverters, central inverters, and other products that we have, VFDs and SVGs. So we are planning to set up, as I want to highlight that we are planning to set up an office and service center in India very soon. So we have presence in multiple countries, and over 6 countries we have sales and service offices, and locally in China we have 30 plus sales and service offices. So in terms of honors, so we have a lot of honors in our cap. But to discuss a few, I would like to highlight that we won the first prize of Shenzhen Science and Technology Offshore Wind Power Converters. And also we have won the first prize of Science and Technology Awards from China Power Supply Society and China Renewable Energy Society in 2022, to highlight a few. So these are the countries that we are present in. We are present in the Americas, in North America, in Brazil, in South America, and then we are also present in Southeast as well as in the Middle East. We are present in Europe, in Germany, in Netherlands. So we are present in terms of sales and service offices. We are present everywhere around the world, and we are supplying them the best quality, the industry with the best quality of power conversion equipments. So these are the product overview for our solar portfolio. So we have a complete range of inverters from 3 kilowatt to 110 kilowatt in terms of residential and CNI, and we have utility inverters, utility string inverters 250 and 350 kilowatt, 385 kilowatt, and we have 3.125 centralized inverters as well. We are also having hybrid inverters from 5 to 12 kilowatt, which are in high demand in India, as we can see. So these are the product portfolio. We have a complete range of products, as you can see. So let's discuss about the PV string inverters in residential and CNI. So for residential, this is a typical schematic where you can see our residential inverters are connected one side with the panel and the other side it is the grid. And we are connected with the Hope Cloud, which is our own portal, monitoring portal, which is connected through the Wi-Fi dongle. And we have our own web and app-based applications and mobile-based applications where we can monitor the projects. And this is how this is one of the features in our residential as well as CNI segment, CNI inverters as well. This is a typical zero export solution, how it is connected, as well as how we are connecting multiple inverters in daisy chain for by using RS485 for monitoring. So as you can see, we have meters. We have smart meters, Hopewind smart meters, which can be utilized for zero export solution as well as for connecting multiple inverters. So we have Hopecom box here, where multiple inverters can be connected through RS485, and the same Hopecom box can be connected to the Hope Cloud through Wi-Fi dongle for remote monitoring. So this is a typical feature in our CNI inverters, where we have provided two cases available from our competitors, from solution 1, solution 2 as two cases, and how Hopewind is overcoming this problem. So as we can see in the latest 670 watt modules of various module manufacturers, the IMPP, the maximum current, is more than 15 amperes or more than 16 amperes. So it is, in this case, it is 17.55 amperes. So in the first case, as you can see, for various inverter manufacturers, the maximum input that you can give is 16 amperes, due to which 20% loss occurs. And in second case, they recommend to use Y connectors. So in terms of Hopewind, if you are using a Hopewind inverter, this can be omitted. We don't need a Y connector because our input can handle up to 20 amperes, and we will save that extra 20%, since our input is can be up to 20 amperes. So this is the PID recovery feature, where our 60 plus inverters, our 60 kilowatt plus inverters can provide. So for our PID recovery during the night time, our inverter sends some repairs the panels, as you can see, during the night time. And after recovery, as you can see here, before recovery, when a 540 watt module is giving 469, after recovery it is giving 520. So this is the case where we are saving at least 10% of generation. So we have this feature, and as you can see, it is a very critical, since more than 50% of the generation could be lost to PID. And this is let's talk about our feature, about monitoring feature. So we have this monitoring feature that can work in AC and DC dual power. We can monitor for 24/7. That is another feature, and we can do remote monitoring, remote monitoring, remote firmware updates during night. So during the daytime, during generation, we don't have to update the monitor the firmware. And this can be used for preventive maintenance. We get notifications from our Hope Cloud portal for preventive maintenance. If something goes wrong in the DC side or in the AC side, we will get continuous notifications. So these are the web interface and the mobile app, which includes all the mobile apps, which includes all the features and all the parameters, as you can see. So now I would like to hand over to Anuj, so that he can discuss something more about our utility inverters. Hi, Anuj.
Hello. Hi, Sandeep. Thank you. Thanks for the beautiful presentation.
Hi, Anuj. Can you share your screen?
Yeah, 1 second. Yeah, is it visible? Hello, is it visible?
Yeah, I think it is visible. Yeah.
Okay. Hello, everyone. Good morning. Myself, Anuj Mathur, looking after the Northern India sales as a regional manager for the utility projects. So let's talk about utility inverters. We have two models. Yeah, we have two models, 250 kilowatt and 385 kilowatt inverters. These both inverters are suitable for the harsh environment, like coastal region, India region, and high altitude areas, desert areas. So As you can see, our 385 kilowatt model supports the high watt peak modules having 182 wafer size, 210 wafer size. It has PID recovery features. It has no derating at 40 degrees Celsius. It has HVRT, LVRT features. It also supports PLC communication. IV curve scanning is there, and it also supports AC aluminum cable, AC side aluminum cable. So, for your better understanding, as you can see, we have taken two types of module having different sizes of wafer and different currents. In Zinco module, the IMP current is 13.56 ampere, and in Trina module, it's 18.6 ampere. So, as our inverter has four DC inputs, as our this 385 kilowatt model has four DC inputs with 60 ampere current each MPPT. So for the first case, we have used all four DC inputs, but for the second case, we have used only three strings per MPPT to increase the DC input current, that is 20 ampere. So now a higher peak module could easily connected as we decrease the number of strings per MPPT, which increases the current to 20 ampere. So, if we talk about smart air cooling, our 385 kilowatt inverter has smart air cooling mechanism and heat dissipation to maintain the long-term reliability and performance of the inverter, especially for the high temperature environment. In our inverter, there are temperature sensors, control system installed within the inverter that can monitor the internal temperature. And as per this temperature, smart control system adjusts the cooling mechanism and the speed of the fans. So if we talk about the smart protection, our 385 kilowatt inverter comes with a smart DC switch, which enhances the safety and reliability of solar power plant. This smart switch protection helps to prevent electrical faults at DC side. It comes with some features like over voltage, under voltage protection, over current protection, ground fault monitoring, and compliances with the grids, safety standards and regulations such as IC 62109. If you talk about the intelligent O&M, our inverter supports advanced technologies like IV curve scanning, predict maintenance to anticipate equipment failure, remote monitoring, data analysis, also fault finding with IV curve scanning. Our inverter is compatible with all this powerful approach of intelligent O&M, which maximizes the energy production and overall efficiency of solar power plant, while minimizing operational cost and downtime. As we can see that our inverter has also passed the weak grid adaptability test of China Electric Power Research Institute. So also we also have powerful quality control HVRT and LVRT capability for maintaining grid stability and reliable power supply. Our inverter, this 385, is also supports the PLC communication, where we can connect 15 inverters with our Hopewind box 2000. Using PLC communication technologies, it can reduce the cost of communication cables and constructions, which is reduced by 0.24 rupees. Yes, our inverter has an HDG features, which and can generate up to 60% of power of nominal capacity, setting the power factor to 0.8, which saves the SVG equipment cost. Here is the comparison of different capacity inverters for an array of 3.125 megawatt. You can easily understand the reduced number of units as the kilowatt rating of inverter increases. If an array of in an array of 3.15 megawatt, 225 kilowatt and 350 kilowatt inverter comparison, the 5 unit cost is same. So apart from the inverter cost saving, there is a saving of equipment cost, reduced US cost, reduced O&M cost, and there are lesser number of units and reduced LCOA as well. So here we can see some applications of our inverter. So this is our 200 megawatt project recently installed at China. In the above picture, you can see that that type of environment where our inverter is operating and suitable for this kind of harsh environment and dusty regions. This is the example of this is the 100 megawatt project installed at Shangzi mountain, where we have used 250 kilowatt steam inverter. This is 15 megawatt project installed at Pangjing. This is C&I project where we have used our 50 kilowatt steam inverter. This is 80 megawatt project where we have used 250 kilowatt steam inverter. This is 480 megawatt project where we have used our multiple inverters like from 10 kilowatt to 110 kilowatt steam inverter. This is a 20 megawatt project which is installed at the mountain at high altitude. So our inverter can also sustain the high altitude regions. This is 14 megawatt project installed at Ukraine. We have used 60 kilowatt steam inverter. So this is our example of central inverter case. This project is at China, Hunan. And here we have used our 1.52 megawatt central inverter. This is 50 megawatt project where it is installed at the Shangzi, China. And here we have used 3.125 megawatt central inverter. Thank you everyone. That's all from my side.
Yeah, thank you. That's a good understanding of your products. I was making notes of it. So, thank you for this introduction on the projects also. I wanted to, I had a couple of questions. So I think we can begin the panel discussion now. My question to the developer and the EPC, companies, the representation of developer and EPC companies, Mr. Gautam Samanta and Shivshankar Mishra ji. My question to Mr. Samanta is, as a developer, what is the criteria for you, that you consider while selecting the appropriate inverters with your, advanced technology modules in order to optimize the generation, and also considering there is a lot of change in technology.
Thank you, ma'am. Thank you, everybody, and thanks also to Mercom for giving me the opportunity to speak today. Well, first of all, we look into the LCOE, the first numbers, right? And the LCOE, we see the capex cost plus opex cost, but denominator is the main function in a sense, like how we generate powers, from the systems. If we look at one, then a couple of things are very important over there. First of all, the module, and second is the inverter. So today's discussion is the inverter is the heart of the systems, right? So in the module side, we have switched over, from the poly to mono, and we have seen that from the reliability point of view, on a year-on-year basis, in the mono park, which is giving the first year, though they are giving 2%, degradations, and year-on-year is 0.45, on the glass bifacial module monopark, because nowadays popular is the bifacial modules, right? So what I want to say that at the end of the 25 years, we get a on the year more than 87%, 87.2% on the power. So therefore, the most reliable in terms of the power. First of all, the module, what is this nowadays is a 545 to 550, right? I'm talking in both the formats, whether it is that M10 or M12 or G12, what we are talking. So from the inverter perspectives, in the solar systems is the most, what I will say, the reliable system it should be, whatever the best module we install, So if the inverter is not functioning properly, so there are different criteria for selecting inverter as well, right? Okay. So first of all, we have to look into what is the AC block size. Next thing is that, the DC overloading. So nowadays, the earlier it was 1:1 DC AC ratio. Now it has gone up to 40% or to 50%. I will give an example on that, how it is going. And the next important factors is the efficiency of the inverter, like efficiency of the module, as on today is 21.2, 21.3, and with the 23% monopark cell, right? But efficiency of the inverter is also very important. Like it should be above 98.8%, And next thing is the uptime. Uptime means what we want, something like, is a 99%, where it should work, otherwise things will not as per our desired systems. Next is that, the operating temperature. In the operating temperatures, as you know, in the cell level, that's the silicon devices, there is a temperature factors, and the monopark, like 0.34 to 0.35 millivolt per degree Celsius per cell, And way forward with the new technologies, definitely like the TopCon and the HGT, it will be an advantage, particularly in India, in terms of the less degradations with respect to the temperature. The same thing like here in the inverter itself, it is also very important that how it is operating. So inverter is not only from the design perspectives, but also one of the factors like I want to mention over here, as far as the design is a 1:1 ratio, there is no clipping on that, but in case of a overloading, and particularly in the peak hours, there will be huge clipping. So that means there are several tremendous stress on the inverters, right? So inverter is a performance, like, it has to be guaranteed. Say if it is my say 100 megawatt project on the AC side, it has to deliver. So therefore, the DC side, there is a huge overloading, and it has to be the clipping mechanisms in such a way that it should effectively work on that, to achieve these things. But also there are several other factors, say for example, the forecasting and the other mechanisms. We'll discuss maybe in a later stage, as well as on the reactive powers, how it works and how we'll maintain the overall systems and all. Thank you, ma'am. Thank you, and we'll discuss it later.
Sir, I have the same question for you. As an EPC, a service provider, what are the criteria you look while selecting the right inverters, and especially when you have your, other cost constraints also?
Yeah,
Mishra ji.
question is with me.
Yeah. Yes, sir. As a EPC service provider, what is the criteria you look for while selecting the right inverters?
Yeah, thanks. And it's great to have an interaction platform where all experts are there. And yeah, definitely this we again because I work from both sides. So as a one side, very long tenure, more than a decade.
Yes.
And then now I am seeing the other part, as you were mentioning. It is very important to see both the part in actual sense. If you work both the part, then you will realize the issues with other part also. Definitely, say the owner as an EPC company, if we have to create value for the owner side. And many times we have seen that a lot of practical experience, technical know-how, competence, capability to understand product. It's very important, rightly pointed out by Hopewind team and Gautam ji also. it is very important before initializing thing. It is very important to understand and select the product for a particular site also. It's a thorough investigation, and many times at the EPC also I have seen that many owners try to slip that. Maybe because of maybe lack of understanding, deeper understanding, I will say. Understanding is there. I hear the phrase should be deeper understanding. From facial value, it may not be visible part, but if we go to the deep part and understanding level, then it's an inverter selection, module selection, it's all and site selection. All three triangles, these are the vertex point of all three triangles. You have to take care the site specific. Many times we have to change the technology, we have to change the inverter selection criteria also, and selecting the module part and the technology like tracker, without tracker, and flexibility in the at the site also. So these are the criteria to create a value for the project. So as a EPC, we have to, and it's very difficult work for us as a EPC, because we have to create different options and value propositions to owner. We have to present many things.
Yes.
At the same time, and with a lot of reliability and say confidence. And that way, it is very important. I think Anuj has brought out in these days, inverters working in the grid compliance mode, it's a real challenge. And I've seen from owner side also interacting with a lot of statutory body. So that also, if the inverter is supporting with a low SCR level, short circuit ratio level, and these inverters, that's very important point. That's very important point. So it's a complete package. I will say, Priya, it's a complete package. It's not a one solution. It's a complete one. And as the Gautamji has told, the ultimate LCOE, the literal meaning of LCOE as an owner also should look for the whole project in a longer cycle time, not as a first year, second year, third year. No, it's a long-term perspective. O&M flexibility, O&M aspect, how you have a target, how competent you are for in the O&M stage. So it's a whole of a package, in my opinion.
Right. So Anuj, you tell us, there's a lot of demand for now string inverters pairing with high power rated modules, right? How do you think string inverters work more efficiently with the new technology modules?
Okay. Yes, the string inverter with the higher capacity, such as 250 kilowatt, 350 kilowatt range, can play a significant role in increasing the ROI of the solar projects. I mean, it reduces the equipment cost, US components, lower installation costs, improve the system efficiency. It enhances the monitoring and control. It maintains the efficiency, warranty and longevity, grid integration. Like in some cases, grid operators and utility may prefer or require larger inverter for grid integration, especially in the utility scale solar projects. So using inverter that meets these requirements can make it easier to connect your project to the grid. And space saving as well. If we are using fewer inverters with higher capacity, can save space in the inverter room or container, and reducing the physical footprint of the solar installation, and potential lowering land or infrastructure costs. Yes, that's all.
Okay. And Sunil, what are your observations about solar projects in India? How are they unique compared to projects in other geographies where you are supplying inverters to? And how are you catering to these specifications in the market?
Yeah, so India is a very vast country. So we have snowfall here, we have desert here, from the Thar desert to the plains of Tamil Nadu. We have everything in India, right? So for this applications for these different geographies, we constantly work on the R&D, because we are supplying inverters throughout the world. So for different geographies, different environmental conditions, and for different, like somewhere we'll find very high humidity in the Gulf, or somewhere we'll find very high temperature rising up to 50, 55 degrees. So for that kind of situation, we have already supplied, and we have already worked on the R&D to produce such kind of equipments for such environments. So basically, in India, it's a mini world, it's a mini Earth. So we have to provide we have to provide such kind of equipments in India, all through maybe a decentralized project somewhere in the mountains in Uttarakhand, or in the desert, utility project in this desert of Thar, or in Rajasthan in Barmer, or somewhere in the plains of Tamil Nadu in Coimbatore. So we are prepared. We have our projects, our products that can be useful in such kind of environment. And yeah, so basically our R&D is so strong, and we have already supplied so many and so much of our products in such environment, and we are pretty confident about our products in India.
Right, right. And going back to Mr. Samantha, we talked about how what are the criteria that you seek while you have to select inverters. So my question is, what can go wrong if the right inverters are not selected, and what is the result of choosing the right best inverter?
Yes, I'll give an example. As I was discussing, so like there is a, say for example, 545 module wattage. So two different kind of a format that we had seen, that whether it's a M10 or M12 or G12, right? So in the first case, it is a M10. So the module has a current is something like 12.5 amperes, and the voltage somewhere is 43 volt, right? So inverter levels, when we design, say for example, string, I'm talking the string inverter, 180 watt, right? So normally what we do, actually, we multiply, like 1500 volt systems, I mean, it is divided by each module. So normally is a 28 numbers of modules we connect to make a string, or the kind of, in the layman's language, it's called table, right? Okay, so the kilowatt, something like the 15.2 kilowatt, right? And the other format, like if we go for M12 or G12, the current is 17.5 amperes, but it's a low voltage, something like 31 volts. So you can accommodate more numbers of the modules in that, and which will be producing, if you multiply either with the 36 and these things with the 31, then it is close to 20 kilowatt. So in a 1:1 ratio, right, AC/DC. So somewhere you need, for first case, in a low current and high voltage, you need something like the 12 numbers, and next one you order numbers of the string. But when we do a kind of a overloading, say for example 40-45%, in that case, what will happen, something like in the first case we can accommodate 17 to 18 numbers of string, and the second one we see like the 13 to 14 numbers of string. So from the design perspectives, we have to be very perfect on that, and obviously looking, as I told you, the climatic conditions where we are operating and how much is the voltage losses in that we have to take into the considerations. The other point is like, as we have seen that these are the parameters are based on the current, because the voltage is not an issue for module as well as for inverter level, but the current is dependent upon on the insolations, by the intensity, right? In the beginning, in the morning, you get a low current; in the daytime, you get a more higher current. So what I want to mean that the clipping mechanisms is to be very perfect, number one. Number two, you have to have a reactive powers, compensations, and the reactive power is also a very integral features of the of an inverter, right? Okay, so there are a lot of inductive loads either in the daytime or in the night time. So you have to have a current flowing, and which is creating an electromagnetic, a field to operate this kind of equipment. So these are the main reasons if we don't select these things. And also on the warranty side and also supplier side, there are several the contract that when we sign, and also the spare parts mechanisms, and also we have to see that what Anuj and Sunil has told that they have a different kind of the offices in the different regions. But even then, we have the low turnaround time in case of any failures. Are the things are spare is available in a remote site or not, or somebody can if somebody can operate through the VPN or something like that. So there are I'll say we have to have a kind of a foolproof systems, and as long as with a different kind of either from the warranty mechanisms or from the spare parts mechanisms, apart from the technical features of what we have discussed. So this is, I believe, that. Thank you.
Yeah, that was what I wanted to even discuss. Mishraji, my question to you is, see, one thing is you have to balance, the best quality inverters with the right cost. And the other one is now, grid security is another thing that been discussed much more than before, because now there is larger capacity of integration of renewables. So how are inverters going to play a role in providing the grid? And how could developers select the kind of inverters that provide this kind of a support?
Yeah, very important and live issues. It is haunting many of project owners, and particularly EPC company also has a lot of very tough time to select the inverter, even the technology, the kind of flexibility we have, and then overall to meet in the system. If I go back a little bit away from the base thing, the project owner must see and examine the project flexibility in the, say, layout, flexibility, the kind of symmetrical arrays, how much you are in real sense you are able to achieve. Here play a role. Many developers, I really give a point to them that they give a lot of flexibility that actually I have to operate plant in the future also. So even whatever the scale is, say maybe in gigawatt term or in say utility scale project, they give the weightage of point for the operation stage of the plant. So I gave this point. It was my personal point also. I used to give a lot of weightage to string inverter since maybe 5 years down the line. If I calculate, I was giving a lot of weightage because it gives a lot of flexibility for as a owner and value proposition in the O&M stage, and wherever if it is a problem, you will immediately come to know. It's not like see there are checks and balances in central and string. So both checks and balances, we have a lot of solid advantage in string inverter. There is no doubt, but still here I will suggest Hopewind team that there are recent issues, grid failure issues in Rajasthan, where statutory bodies, I think Anuj also might be aware, because he used to interact from another company side, and there are a lot of issues with even central inverter. There are issues with string inverter also for the setting point of view, for the integration point of view, grid compliances point of view at a utility scale project. If there are, because it is a spread one, so that let there be, and I have seen developer from the grid compliance point of view at the detailed investigation for central inverter also, for detailed investigation study with the actual model, PSCAT model, PSSE model, benchmarkings, and with different SCR level short circuit ratio at the grid connecting point, at which point we are connecting, and then suggested remedial measures, fine-tuning the parameters of inverter to sustain in the grid. And a lot of these failures were on primarily to contributed because of the wrong setting, also because of not a detailed study and then set the inverter points. So the inverter is a real heart, as Gautam also told. It's a real sense of the heart of the project. In grid compliance point of view, it's everything. If you have not selected the right one and not have a flexibility in the inverter, then you are nowhere then. So at that point, I really suggest to Hopewind team that you carry out a detailed study, appoint a consultant, I will say, and carry out a study with detailed study for all the parameters, because it is spread. And once, say, the transient happening in the grid point, fault is happening. So how it is behaving in the LVRT in one unit, another unit, and there are so many units. So in past, it was observed that there was some tripping in some of the group of inverters because of the coordination in the settings. It's a spread, and because the layout point of view, because of the impedance changing with respect to farther inverter and the lower side inverter up to the POI point. So because I was involved in this analysis also, so I'm able to comment on this point also. But the value proposition, what is there in the strong side of string inverter, should be given, the developer should be given a confidence with a thorough study that yes, I'm here standing and fulfilling all the conditions and requirement for utility scale project also. So although one side there is a lot of flexibility, you have of course a string inverter has got, everybody knows that multi-MPPT point. If you have a change in the layout, you can manage the layout change, you can manage the situation change also, even with tracker also. Some tracker is operating, some tracker is not operating, some trackers are exactly not aligned with the angle of rotations. So in those this is the strong point for string inverter. So let us you go through a study point and prove that on platform. This will help the developer also, and this will help as EPC also, us also. So this study with open mind, it should be done and proven on the say as per the actual data grid compliances study in all format, whether it is harmonics, whether it is the set points, everything. Thank you.
Yeah, that's a good point. I would have Anuj reply to that, but along with that, my question would be, how are these string inverters increasing, especially with the higher capacities, increasing the ROI of projects? And also, I'm going to club another question also. How are these smart inverters, that helping regulate the reactive power supply? Because Mr. Samantha and Mr. Ajit both have talked about it. Reactive power as well as the voltage of power grids, and how important is it for solar projects? What are you hearing from the developers and EPC companies?
First of all, I'd like to thank FF Mishra sir for guiding us and pointing some important points related to the inverter issues happening outside. So yeah, coming to the question, certainly the smart inverters, also sometimes called advanced inverters, are leap forward in inverter technologies and are critical to the evolving electric grid, especially with the rapid integration of distributed energy resources like solar photovoltaic systems. Smart inverters go beyond the basic function of converting direct current produced by the solar panels to the alternating current suitable for the grid. So they come equipped with sophisticated software and hardware capabilities that allow them to interact dynamically with the grid, perform advanced grid support functions, and improve the integration of renewable energy sources. Like regulation with the reactive power and voltage. Reactive power is needed to maintain voltage level in the grid, Smart inverter can both consume and produce the power as needed, helping stabilize the grid voltage. This feature is typically referred to as a voltage VR optimization. And about the voltage regulation, fluctuation in the solar energy productions due to the cloud cover or other factors can lead to voltage variation in the grid. A smart inverter can automatically adjust their power output to help maintain voltage within the specified limit. They can either reduce their output during high voltage or even absorb power during low voltage scenarios.
Okay. Okay. And Sunil, what are your plans of setting up any manufacturing in India? What kind of opportunities you're seeing? And what are the the module technologies do you think will be dominating the Indian market? Because that is how you will be, probably proactively thinking about providing the pairing technologies with your inverters. And how is Hopewind preparing to address this demand from the Indian market?
So as you know, thank you for the question. And as you know, for modules in module technology, since 2020, we are hearing about monoPERC. So
Yeah.
monoPERC was the blue-eyed boy first for the module industry. And now, as we can see that after monoPERC, we are hearing about TOPCon modules, and then after that HJT. So I kind of believe that in the next 5 years or 3 to 5 years, TOPCon will be the blue-eyed boy now, and after that we'll hear the HJT technologies coming up. So basically there are difference of 2 to 3% of efficiency, as Gautamji has mentioned before, between these modules, with these technologies. So we are prepared because see, our inverters are already are compatible with the 670 watt modules, and with the high current input from the high power and current input from the modules, our inverters are already compatible with that. So we are continuously evolving and keeping up with the pace at which the module technology is changing. So we are keeping a very keen eye on the coming up technologies. So for us, the next technology is going to be TOPCon, and after that it will be HJT. We understand that for HJT in India, it requires a lot of capex as compared to monoPERC or the TOPCon. But we understand that it will happen. It will happen. HJT is going to come, and I think already some big players are working with it and working on the technology to reduce the cost per gigawatt production cost. So we are looking forward to that, and we are prepared for the latest technologies to imbibe those technologies and provide the best inverter possible in terms of R&D and in terms of continuous responses and continuous feedback that we get from people like Mishra ji and Samantha ji. So we are very grateful to them for giving them their inputs, and we try to imbibe all their inputs in our technology. We give this feedback back to our R&D, and our R&D will continuously work on that, and we'll produce some better quality, best robust inverters for the Indian project developers.
I'm sure about that. So the one question to both of you, Mr. Samantha, this is my last question because we have 5 minutes and we are trying to take some questions from the audience. What are the advanced technology modules and the inverters you are expecting in the next 2 to 5 years? Mr. Samantha and Mr. Mishra, both of you.
Okay, so first of all, can you hear me?
Yes.
Okay. On the module side, I think Sunil has mentioned that we are in the just verging of switching over to the TOPCon. As you know, by end of 2023, globally, there will be 100 gigawatt of productions. And globally, what do you mean by it? Mostly into China, And today, the module productions is in excess of 450 gigawatt level, right? Next, I'll say parallelly, HJT is also measurable. There are companies like who are adapting. If you look at the process point of view, there are a couple of additional steps. are in that from switching over to the monopod to the top cone, but obviously the substrate is different. Instead of a p-type, it is an n-type. So therefore, n-type materials are much better in the device. I don't want to discuss much on that, but definitely they are performing in terms of their both the current and the voltage. They are much better. Current density is as high, closer to 41, 42, and then even cell level I'm talking, and then even the cell level, the voltage is somewhere at 700 millivolt plus, right? So we get an advantage on the in terms of the what I'm talking about, the either M10 module somewhere. The area is like 2.57 square meter. The dimension is like 2272. On the length divided by the width is 1132. So here itself is 21.2%. So way forward it will be 22 and a half. Right. But this is a short. This will I will say short term, in a couple of years. But the next step, what is going to happen? So next step is that the silicon material will be as a base, and on that there will be a peroxide materials, or on the other word, the next one is coming as a tandem. What does it mean? So on the top of it, there is a kind of another inorganic structures, it's called barium titanium structures, but it can be done in a different way, whether it may either spinning or through the the thin layer coating and all. So what will happen is your base layer is something like 24-25% is the efficiency, but you will get an additional 5% efficiency on the top of it. So what does it mean? So somewhere your substrate by 2028 to 30, you will get a 30% efficiency in the module level. And as we are installing, we are talking about, these are all bifacial in nature, number one. Number two is that it will be acting on the single axis trackers, and you'll get an albedo, and then another enhancement. I'll take the bottom line, like maybe 10%. So 330 watt kind of a the module per square meter it will generate, something like these are the things. So Sunil and Anuj, you should be careful on that. So I'm coming back to the high rating current, because in India, as we see that the module what we connect, something is a parallel. So the current what we are getting, let's say for example, from today 12.5 with the M10 concept, then it will going somewhere maybe closer to 14 amperes, and then there will be an albedo, and when you connect it, it is going to some more than what I'll say 32 to 35 amperes, closer to that one. So be careful on that on the current rating. And on the system side voltage, definitely there is a going to change over, then we will discuss maybe in a later say for 1500 volt to 2000 volt, 2500 volt, but it needs to be capable that the module and the bill of materials similarly on the BOS side should be adaptable this kind of the changes, because the high voltage definitely but one of the important fact over here, the n-type material is very useful. On the top is the positive, and the rear side is a negative. Therefore, earlier what happens, because of the PID, some sodium ion used to come, and which is creating a PID effect on the front side. So at least we can avoid that one. But there are some other the bill of material to be changed to adapt the new technology as well as adaptations. But as we talked about a little bit on the smart, either in the module as well as in the inverter side, because the algorithms what you are doing in the inverters levels, definitely current, voltage, power angle, and then the tilt angle is also is a very important factors, and in millisecond how you are tracking and getting this data. So the idea is that in a sum of the energy yield, how you are getting a better energy yield. So ultimately it's for a power plant perspective, so we want to have a peers always something like 83 or 84%, in future, and maybe in the CAF side, maybe closer to 28 to 30. That's the numbers that we have to work for. Sirji, you can talk something on that.
Yeah. Mishra-ji, if you can just tell us.
Yeah, he has very nicely covered the future technology of the module. I also just reiterate from the module side, we have seen for past 6 months or a year, we can say 6 months, how the change has happened from monofacial to bifacial. Now today, bifacial people don't ask for extra money. They have said it is both the same cost. So the change is happening like this. So the same way in the future time to come, you can see the N-type dominating the market, and TopCon is the efficiency because of the intrinsic. Say the India, we have high tropical region, the high temperature zones are here. So here it really matters. It really matters the efficiency, lesser drop in the with the temperature, and the efficiency really it matters, and use millions and millions of units, extra unit from the same installation, it can contribute to the grid part. HJT and all technology, as Mr. Sunil was also telling, a lot of people is after that, and very soon you will be hearing that something new has come. So I will not touch upon major thing already Gautam ji ne bola hai. So I want to hear just to make a point here, the kind of grid integration and the megawatt capacity wise integration is happening in the Indian grid now. So the natural system inertia is going to be lesser and lesser in the time to come. So by 2030, you can say the internal target of 500 gigawatt by capacity, it has to be RE integration to be there. So we are going from say the conventional generation with the inertial support to the grid, that will be minimized, that will be reducing, and that will be taken over by say RE generators. So that challenge, I'm seeing a requirement of future smart inverters, which will cater the requirement not only from the inverter point of view. It is a future is from grid forming. You can say a hybrid. I can expect from Hopewind team and others team also. Whenever somebody interacts with me, I can suggest that the today inverter is functioning only for an inverter thing, but tomorrow it has to support like a StatCon, which will give immediate support, say reactive power support, say grid forming inverters, that is some kind of artificial inertia it is supporting, replacing the conventional generation, and the hybrid one also. Tomorrow, in the future time to come, inverter function will be a hybrid one. So the StatCon mix, SVG StatCon mix functions, and with the normal inverter. So I can see that these inverter manufacturer must be doing a lot of R&D also on that. If we club these two, probably it will be a better economics and better functions of the inverter. With the low short circuit ratio in the grid, it is very difficult to operate grid. So that challenge, grid integration point of view, I can see there is a lot of change will happen in the inverter technology perspective.
Right. So I will, we've already passed 5 minutes, but I'll have Sunil and Anuj. First to Sunil, what new advancement you heard the developers and the EPC service providers? What is the demand, and how you can address the demand and also add to the ROI, because reactive power supply is going to be costly for the developers also. What new advancement can developers expect from Hopewind? And in another year or two, because technology is fast changing, and what are some of the innovations that you are working on?
So currently we are working on higher capacity string inverters with the same platform that we have, the robust ones, where all the technology needs and all the needs of the grid, so that this SVG functions that we are talking about, so that we can support the we can provide the SVG function at night, and it is as good as a StatCom, where we can provide the SVG and we can reduce the cost for additional SVG equipments. So these are some of the demands from the industry, and we have already started working on those, and we already have some products which support night SVG solutions. So currently we have a 385 kilowatt string inverter, which is the highest capacity string inverter in the solar industry right now. So we are working on it to improve it for the Indian environmental conditions. We have installed gigawatts of 385 in China, but we are but the Indian market is very different, as you know. But we are very keen to work on the R&D and to improve the products every day and to make changes in the firmware if required, wherever required. And we keep on taking feedback from the developers. So that is one thing. And in terms of central inverters, we already have 3.125 megawatt inverter, a central inverter for the Indian market. And we are also working on another in the same platform. We are working on a 6.5 megawatt central inverters that will be coming up in a year or so. So we are constantly working to develop the inverter, our products. As the module technology changes and improves, we have to improve with them. So that's the only thing that that keeps on going. So it's a continuous process for the R&D to take feedback from the customers, developers, and to work on it and come up with a better product.
Correct. Anuj, do you want to add to that?
Yes, definitely. Our company Hopewind is doing research and development on the latest technology inverters, especially the issues that in India we are facing related to the reactive power. So our company is doing some new technology improvement on our inverter. Yes, that's all.
So I'll just take a quick one or two questions because we are already run out of time. I think I'll just pick a couple of questions. So what is the benefit of string versus central inverters in utility scale projects, and why do developers generally prefer string inverters?
Should I speak?
Yes.
Yeah. So actually in 2016, we have done some DOEs, design of experiment, right? So what we did actually those days, central inverters was very popular. And on the same site, what we did actually, with the same configurations, we installed one small, one block, with the string inverters. And we had seen that there is a generations improvement of 2.3%, nullifying on all the other losses, But in the string inverters, if you look at the features, there are 14 features. First of all, if there is a bypass diode failure, then you can detect. If there is a swelling losses, you can also very quickly detect. If there is no power output, you can. If there is a PID losses, you can. If there is a glass breakage, you can. If there is a shadowing, you can. If there is a cell breakage, you can. So there are different current mismatch, different, a kind of a, there is a low power output or low voltage like that, is a broken cells or it is visible. So these additional feature plus MPPT, you can track these things, very quickly on that, and as we have a remote monitoring system. So what you do actually, if there is any kind of these issues, so we immediately, see this, it is very clearly visible that this is the fault over there, and then we ask the our operator in the site that we go and check over there. So what I want to say in terms of the for O&M perspectives, we have seen there is an enhancement, it's better management. And what we do actually, we keep a spare, say, 6 to 8 numbers of a string inverter if there is a failure on the component wise, so immediately we replace that one. So the turnaround time is much faster, But in terms of the capex, a little higher on that, because of these things. And but central inverters, definitely there are some advantage nowadays. The central inverters are of the range of above 3 megawatt, So particularly there are a couple of components like IGBT and all, it's very important over there, in their functions, because the kind of the trimming losses when you are doing, and what happened, there is a huge amount as a stress coming to the to this component, and then though there is a force cooling system, so, yeah. So there is
question for
there
you.
are pros and cons, but definitely string inverter is the winner. It's not only here, but in case of a single axis with a fixed tilt or single axis tracker systems. So that's my is a better in terms of.
Another question is, what is the AC loss in string inverter compared to central inverters?
That I can't right now. I can tell, but Sivji, if you can say on that,
And how much overloading can be achieved with the string inverters?
Okay, so for a FT, normally what we do is a 45%, right? But in case of a single axis trackers, like something 18 to 20%, that's what we do actually, right?
Okay. And I'm not sure about this, but you can let me know. Module makers are discussing standardizing dimension of silicon wafers, the wafer modules. And will it be helpful for developers to choose the right size of inverters and with this kind of standardization?
Okay, standardization means M10 is very popular nowadays, but G12 or M12, what you see is a bit out of these things in a sense standardizations. But what happens? I think you might be knowing that there is a rectangular cells in a sense like M10 is 182 by 182. The other one is 182 by 210. Trina has developed this kind of rectangular cells. What happens in that? If you look at the width of the module, what I told you, 1132, right? 1132 millimeters. It will be remain same, but on the length side, what will happen? Instead of 2272 or 2278, like 2278 millimeters. So that will be increasing. It will be like 2384 or something like that. So there will be a 120 millimeters increase in terms of your on the length side. So at least from the developers perspectives, what will happen, but there will be an enhancement in terms of the module in a sense like when we switch over from the monopark as on date like 550 watt modules to TOPCon, which is closer to 585 590. But in case of a this one is a rectangular cells, the rectangular and in the module level that will be 650 watt plus, right? So what happens in terms of the same area, in terms of the per square meter area, there will be a huge enhancement at least from 0.4 to 0.5%, improve in the efficiency using this kind of a the solar cells, in the wafers. So it cannot be 100%, standardized, today, right? But anyway, in futures, there is a challenge, as you know, that the thickness of the wafers are going down, in a sense like today 160 micron. So I will give an example. Or the hair diameter is something like 30 to 35 micron. So you can understand. So only this kind of thin cells with the larger substrate, there will be a lot of micro crack. We can develop, we can discuss some other time, on the solar cell technology or some other format, the kind of the challenge that industry is, but there is an automations and other things. And as you know, that REC or the the Reliance that are coming up, 210 by 105, they are half cut cells. And instead of G12 or M12 in a big wafer, so they make a half cut. So when you make a half cut, that means the mechanical yield will be much improved, rather than a big wafers or big solar cells, right? So that's a big advantage.
We should have another discussion, especially on the new technology modules that are
new
coming
technology,
up.
solar cells, wafers, and on the value chain, either in the ingot or polysilicon. Yeah, sure.
Well,
Sure.
so I think we will have to end the webinar. But Sunil, I will share the questions with you. There are a couple more questions that you can take up offline also.
Definitely.
And,
We will be happy to do that.
Yeah. Thank you for all of you for joining us, sharing your valuable inputs, especially the inputs from the developers and EPC service providers is going to be valuable for all the vendors, whether it is module suppliers or the inverter technology, upgradation that is going to happen in the next few years. So thank you so much, and thanks to all the attendees for being here, for joining us, and do share your feedback and any questions even after the webinar, so we can share it with the experts and they can reply to you. And
sure.
Thank you.
Thank you.
I wish you all the best and have a good day.
Thank you. Thank you, everyone. Thank you,
Gautam
Gautam.
sir.
Thank you,
Thank you,
Shivji.
Shiv sir.
Thank you.
Thank you, Shiv sir.
Thank you,
Thank
Priya.
you, Priya and Mercom
Thank you,
team.
ma'am. Thank you.